Yes, good morning, students. Today I am taking some more questions from exercise 6.3, which are very important for examination point of view. Here, from exercise, question number 18, for the curve y is equal to 4x cube minus 2x power 5, find all the points at which the passes tangent passes through the origin. Here there is a difference in another questions and in this question. It shows that tangent passes through origin, but the intersection point of tangent and curve is not origin. At origin is a different thing. Here the question is tangent passes through origin. It means the touching point of tangent and curve are different. So for solution, the curve y is equal to 4x cube minus 2x power 5. Differentiate both sides with respect to s. This is the process. Find dy upon dx, that is 12x square minus 10x power 4. By differentiation we get this. Now take some point which is the intersection of tangent and the curve. So suppose that point is x1 y1. So we have to find the slope of tangent at x1 y1, that is m. So put the value in dy upon dx as x1 y1. Here it becomes 12x1 square minus 10x power 4. So equation of tangent, we know that the formula y minus y naught is equal to mx minus x naught. That means here x1 y1 is x naught y naught and m is given from above, slope of tangent. Thus it becomes y minus y1 is equal to 12x1 square minus 10x power x1 power 4 into x minus x1. And it is in the question, this tangent passes through origin 0 0. It means 0 0 will satisfy the xy in the equation. So it becomes 0 minus y1 is equal to 12 x1 square minus 10 x1 power 4 into 0 minus x1. After solving it, we get y1 is equal to 12 x1 power cube minus 10 x1 power 5. After solution, we get this. Say it second. Now this point x1 y1 will be also on the curve, so it will satisfy the equation of curve, which is originally given y is equal to 4x cube minus 2x power 5. Here x1 y1 will satisfy this. It means y1 is equal to 4x1 cube minus 2x1 power 5. See it third. Now solving these two, we can equate both the values of y1 from second and third. So it becomes 12x1 cube minus 10x1 power 5 is equal to 4x1 cube minus 2x1 power 5. Taking all one side, we get 8x1 cube minus 8x1 power 5 is equal to 0. You can take common 8x1 cube. it becomes 1 minus 8x1 cube into 1 minus x1 square is equal to 0. Here product of 2 is 0. So that will give you 8x1 cube is equal to 0. So x1 is equal to 0. And similarly 1 minus x1 square is equal to 0. So x1 square is equal to 1. So x1 is equal to plus minus 1. So we get three values of x1, 0, minus 1 and 1. Now when x1 is 0, from third y1 will become also 0, because from third you see here in third it is given y1 is equal to 4x1 cube minus 2x1 power 5. Put the value there and you get y1 also 0. So point becomes 0, 0. That means x1 y1 is equal to 0, 0. Similarly, when x1 is equal to minus 1, then y1 become minus 2 from third. So point x1 y1 become minus 1 minus 2. Similarly, when we take x1 is equal to 1, from third we also get y1 is equal to 2. So the point become x1 y1, that is 1, 2. Thus here we have 3 points 0, 0, minus 1 minus 2 and 1, 2. Here question number 20 is in the exercise. Find the equation of the normal at the point am square to am cube for the curve ay square is equal to x cube. Here we have the question of curve ay square is equal to x cube. Differentiate both sides with respect to x. We get a into differentiation of y square is equal to differentiation of x cube. So a 2y dy upon dx is equal to 3x square. So dy upon dx will become 3x square upon 2ay. But point is am square comma am cube. So put the value of x as am square and value of y as am cube. So it becomes 3am square whole square upon 2a am cube. After solution, something is cancelled out, common part, you get 3m upon 2. So slope of tangent is 3m upon 2. Now the slope of normal, that will be at the same point am square am cube will be equal to minus 1 upon slope of tangent, that is minus 1 upon 3m upon 2. That becomes minus 2 upon 3m. M is in numerator, m is in denominator also. So minus 2 upon 3m. Now the equation of normal using the same formula y minus y naught is equal to mx minus x naught. So y minus y naught here y1 is am cube is equal to minus 2 upon 3m into x minus am square. This is the equation of normal. Now here question number 23 is prove that the curves x is equal to y square and xy is equal to k cut at right angle if 8k square is equal to 1. Before solving this, we have to recall the condition and the concept. Two curves intersect at right angle if the tangent to the curves at the point of intersection are perpendicular to each other. These curves are also called orthogonal curves. So, using this concept, what will you do? First step, you are given two curves, x is equal to y square and xy is equal to k. First find the intersection point of both. Intersection point of both will be solving these two by some way. Here we have x is equal to y square from first and xy is equal to k from second. Put the value of x from first to second, that we get y square into y is equal to k. So y cube is equal to k, that means y is equal to k power 1 by 3. And since x is equal to y square, that means x is equal to k power 2 by 3. Here y is placed by k. So it becomes x is equal to k power 2 by 3, not y. So the point of intersection is equal to k power 2 by 3 comma k power 1 by 3. xy will make the point. So put in coordinate form and you get point of intersection k power 2 by 3 comma k power 1 by 3. This is the point of intersection of both the curves. Now you have to find the slope of tangent at this point to both the curves. How will you find? You will differentiate the equations. Differentiate equation first with respect to x. We get 1 is equal to dy upon 2y dy upon dx. That means dy upon dx is equal to 1 upon 2y. Now slope of tangent at the point of intersection, that is k power 2 by 3 comma k power 1 by 3, it becomes 1 by 2 into 1 by 2y, that is 1 by 2 k power 1 by 3. Say it m1, slope of first tangent to first curve. Now another equation is xy is equal to k. Differentiate both sides with respect to x. So we get x dy upon dx plus y into dx upon dx is equal to d upon dx of k. Using product rule, you get x dy upon dx plus y into 1 is equal to 0. So dy upon dx is equal to minus y upon x. Now the slope of tangent at the point of intersection k 2 by 3 comma k 1 by 3. Put the value of y and x and y, you get minus 1 upon k power 1 by 3. Now say it m2. Here both curves are perpendicular, that means both the tangents are perpendicular. So that means m1 into m2 is equal to minus 1. Now put the value of m1 and m2. You get 1 by 2 k power 1 by 3 into minus 1 by 2 k power 1 by 3 is equal to minus 1. So you get 1 by 2 k power 2 by 3 is 1. Now cubing both sides, you get 1 upon 8 k square is equal to 1 cube, that is again 1. So we get 8 k square is equal to 1. This is the required condition. Now some questions are here for assignment, and one important question is here from your exercise, that is find Find the equation of tangent and normal to the hyperbola x square upon a square minus y square upon b square is equal to 1 at the point x1, y1. Here equation of curve is given. X1 square x square upon a square minus y square upon b square is equal to 1. Here point on the curve is x1, y1. So it will also lie on the curve. So it's x naught, y naught. So it will also lie on the curve. So it means it will satisfy the equation. So it will become x naught square upon a square minus y naught square upon b square is equal to 1. This is step number 1. Now you have to find the slope at this point. For finding the slope, you will differentiate the given equation both sides with respect to x. Here a square, b square are constants. So it will become 1 upon a square d upon dx of x square minus 1 upon b square d upon dx of y square is equal to d upon dx of 1. So that becomes 2x upon a square minus 2y upon b square dy upon dx is equal to 0. That implies dy upon dx is equal to minus 2x upon a square into b square upon minus 2y. That becomes b square upon x upon a square y. After solution we get this. Now we have to find the slope of tangent at the point. So slope of tangent at point x naught y naught will become b square x naught upon a square y naught. So the equation of tangent at the point x naught y naught will become y minus y0 m x minus x1. Above is m. So y minus y naught is equal to b square x naught upon a square y naught into x minus x naught. So now you have to take b square left side and y naught is also left side. So it becomes y naught upon b square minus y naught square upon b square is equal to x naught upon a square minus x naught square upon a square. Simplifying, you can get this. After more simplification, you get x naught a square minus y naught b square is equal to x naught square upon a square minus y naught square upon b square. And it is from 1, it is from 1, right hand side will become 1 because x naught and y naught point is on the curve. So x naught square upon a square, here it is a square not a, minus y naught square upon b square, this will become 1 because it lies on the curve. So it will satisfy the equation of curve. Thus we get x naught upon a square minus y naught upon b square is equal to 1. This is the equation of tangent. Similarly, equation of normal is at x naught y naught is y minus y1, and the slope of normal will be minus 1 upon slope of tangent. So it will become minus 1 upon b square x naught upon a square y naught into x minus x naught. So this becomes y minus y naught is equal to minus a square y naught upon b square x naught into x minus x naught. This will be the equation of normal. Now you can simplify this also. Now here another question is from the exercise. Find the equation of the tangent to the curve y is equal to under root 3x minus 2, which is parallel to line 4x minus 2y plus 5 is equal to 0. We have equation of curve and tangent is parallel to this line, so we have to find tangent slope of tangent from the curve and the slope of this line and equate both, we can get the result. Here we have y is equal to under root 3x minus 2. So dy upon dx is equal to 1 upon under root 1 upon 2, as you use power rule and then chain rule. 1 upon 2 3x minus 2 whole power 1 upon 2 minus 1, it will become minus 1 upon 2. So it become 1 upon 2 under root 3x minus 2 into d upon dx of 3x minus 2. So d upon dx of 3x minus 2 will give you 3. Thus we get 3 upon 2 under root 3x minus 2. Now the slope of tangent is equal to 3 upon 2 under root 3x minus 2. And the slope of line 4x minus 2i plus 5 is equal to 0 is equal to coefficient of minus coefficient of x upon coefficient of y minus a upon b. So it will become minus 4 upon minus 2. So that is 2. Since tangent is parallel to the line, it means slope of tangent is equal to slope of line, and slope of tangent is 3 upon 2 under root 3x minus 2. That will be is equal to 2. So we get 3 is equal to 4 under root 3x minus 2. Squaring both sides, you get 9 is equal to 16 3x minus 2. Thus we get after solving it, x is equal to 41 upon 8. When x is 41 upon 8, put this value in the original equation, we get after solution y is equal to 3 by 4. So point will be 41 upon 8 comma 3 by 4. So we can find the equation of tangent at this point. Y minus y naught is equal to mx minus x naught. So y minus 3 by 4 is equal to, and slope is 2. From above we get slope because tangent and lines are parallel, so the slope of tangent and slope of line are equal. So we get m is equal to 2 into x minus 41 upon 8. So we get y minus 3 upon 4 is equal to 2x minus 41 upon 24. Multiplying it by 2, so it become like this. 48 and 2 cancel out. So it becomes 2x minus y is equal to 41 upon 24 plus 3 upon 4. That is equal to is equal to 0. So 2x minus y minus 23 by 24 is equal to 0. That means after taking LCM we get 48 minus 24y minus 23 is equal to 0. So that's all. Now the topic is completed. You have solved assignment which is provided before this question. Thank you. Have a good day ahead.